0, 7 we are on. We skipped 0, 6. So we went right to 0, 7. Just flip the page so you see 0, 7 at the top, okay? It's not, you can figure it out. All right, here we go. We've got two lines. They intersect each other. That's a good geometry word. Write that down somewhere. Okay, they intersect. These two lines, they intersect, and they hit at a point. We'll talk about that a little bit later on. Think about it. I'm not even going to answer that. You think about it first. I'm teaching this, right? I put section 0, 7. I'm teaching it. So you tell me what you think you should do. All right?
What does it mean again?
The two lines right here are intersecting each other. They intersect. Intersect.
What does that mean?
It means they cross each other. They touch each other at one point, and that point's right there. All right? These two lines just aren't any kind of lines. You've dealt with this before in Algebra 1. I could put an arrow at the end of this one, an arrow at the end of this. I could put an arrow up here and an arrow down there. So this word intersect means the two lines, they cross each other, and they cross each other at this one point right here. But let's talk about these two lines themselves. We call this an axis. When you have a horizontal and a vertical line like this, we call this an axis. Both of these. This is an axis, this is an axis. But we labeled this with a certain letter, didn't we, in Algebra 1? This is the x-axis, so you usually put an x right there. And what was this one going up and down? That was the y-axis. All right? Now that's singular. You have one axis, but let's go plural because I'll say this word from now and again. And the plural of axis is, what do you think? You said axises. Somebody said axi. That sounded kind of cool actually, but we don't say that. Say it. Axes, right. A-X-E-S. The plural of an axis is axes. So we have two axes. An x-axis, a y-axis, two axes. You got it?
That'd be I-E-S?
It's right there. A-X-E-S. That's how you spell it. Axes. I would have put an I there if we spelled it with an I. So it's axes. So look, this point right here has got a name as well. They intersect each other at this point. Well, we don't really call this one the vertex. It does have a special name. Now, we will use the word vertex a little bit later, but this one's not considered the vertex. Anybody say? The origin, right. We call this the origin. The origin is where you begin, okay, where you originate. You ever hear that? That word, it's got the word origin in there. It's the beginning. This is where we start. We're going to talk about that in a little bit here. All right, so that's an origin. Well, these are not just lines. They're number lines, and we put numbers associated with certain points on here. So now if I draw these little marks right here, sometimes the book calls them tick marks, T-I-C-K, tick marks. So they put little marks right there. They represent numbers on the number line. Normally, we just go nice integer numbers or nice whole numbers, so that would be 1, 2, 3, 4. Now, if it goes to the right of 0, 0 would be right there. It's always positive numbers. What if we go to the left of 0? They're always negative numbers. Okay? Freddie, getting all this? Yeah, let's put the cone down or whatever that is. Okay? So watch. What's that? Are you writing this down? Okay. Well, I'm still writing, so have a pencil in your hand. So if we go to the left of 0, we're going to go negative numbers. So we go -1, -2, -3, -4. Now this arrow, what do you think that arrow says? Does it stop at 4 and that's the last number? It keeps doing what? It keeps going. That's right. It keeps going in the right direction, the positive direction. It keeps going in the left or the negative direction. All right, that's what those arrows represent. Now what about the y-axis? What if we go up? What kind of numbers go up? Positive numbers, so let's write those in there, 1, 2, 3, 4, and if we go below, we go negative numbers, so -1, -2, -3, -4. Now these little marks should be evenly spaced. I kind of just put them as even as I could just by looking at it. But you know, if you wanted to be really, really careful, you could either use graph paper or you could use a ruler or something like that to make sure that they're evenly spaced. But I'm just doing it like that. All right, we good with that? This whole thing, this whole situation, that x-axis, y-axis, the numbers and all that kind of stuff, it's got several different names for it, okay? And I'm going to write down a few names just in case you hear them some other time. Some people call this the rectangular coordinate system. Coordinate. Look at that crazy word. Okay? System. All right? The rectangular coordinate system. Some people call it the, oh my goodness, what was the other one? I think I was just thinking of coordinate system. Anyway, there's another crazy name. Most people call it the rectangular coordinate system, but here's a name that you may not have heard before. Sometimes some people call it the Cartesian coordinate system. Cartesian. Now, the reason it's called Cartesian because it's named after a guy, and you'd think his name was like Cartesia or something like that, but the guy's name actually has a girl's first name. Well, what we consider a girl's first name is his name is Rene. Right? I think he's a French guy. I don't know. You probably have some accent on there somewhere. I don't even know if it's two E's. It might just be one E. But René Descartes. This guy was really actually pretty important. He did a whole bunch of stuff. He didn't just come up with this thing. He did a whole bunch of other stuff. But that's who this is named after. René Descartes. Some French guy back in who knows when, 1600s, before, I don't know exactly when. I've looked it up at some point. I just can't remember. You can look it up if you want. But anyway, he's the one that basically gets credit for this coordinate system right here. It's the Cartesian, right? The Cartesian coordinate system, or the rectangular coordinate system. That's perfectly fine. All right, just thought I'd throw that in there. It probably won't even be on a test or anything, but I think it's good to at least know. All right, let's not get that. All right, we'll get rid of that. All right, this is what we're trying to get at. We're trying to label points on here, or coordinates. That word coordinate that I wrote down on there, let's write that down one more time. Coordinates. That's an important word. A coordinate basically just means a location, where something is being placed, where it's located. All right, that's the coordinate of a certain point. A point is just a dot. It's just a place where something's located. So let me put a dot like right here. All right. Now look, if it looks above the 3, it's above the 3. If it looks like it's across from the 2, it's across from the 2. I'm not trying to be real picky and saying, oh no, that looks like 2.9 or that's 2.1 or something like that. No. If it looks like it's above the 3, it is. All right. So let's just go by that. This point right here, this dot, has a certain location. I want to figure out where that location is, where it's located, what its coordinate is, and that's what they're going to ask you in the book sometimes. They're going to say, what is the coordinate of this point? And so they'll stick a point right on a graph. They might even label it. They'll call it like point A or something. They usually use a capital letter to represent the point. So they'll say, okay, here's a point. Tell me the what? What's that word? The coordinate of point A. So this is what we do. We label these things with things called ordered pairs. You guys remember doing that last year? Yeah, ordered pairs. An ordered pair, well, what does the word pair mean? P-A-I-R. Okay, it's not a piece of fruit, but it's two, right? Two things, right? Pair of shoes, two things. Ordered means it's in a certain order. You got to pair them up in a certain order. That's right. The X always goes first and the Y goes second. That's easy to remember because it's just alphabetical order. All right, so an ordered pair is X, comma, Y. Put it in parentheses. Don't forget the parentheses. There's a certain way you have to write them, and that's the way you want to write them. Now look at point A. This means you always start where? What's the beginning? Now, what's the beginning? The origin. You always start at the origin, which is right here. Okay, right with that point of intersection. And then it says, to find where this point is, you go in the X direction, and then you go in the Y direction. All right, so we're not just going straight up to it. It's kind of like a city block, right? If you're in New York and you're driving down the city, if you want to get from point A to point B, you don't usually in New York just drive straight across like that, do you? All right, you'd have to go down this block, across this block, wouldn't you? All right, but in this situation, we're going to go in the X direction first, then in the Y direction. Start at the origin. So let's see. How far over and what direction? 3 over to the right. Okay, we'll say right and left, up and down. Okay, so we go 3 to the right, and then what? 2 up. Okay, so we go up 2. So 3 to the right and 2 up. That's how we get to that point A from where? From the starting point, from the origin. All right, so I'm going to go 3 to the right and 2 up. And this is how we show it. We write 3, 2. That's our ordered pair. That's how you find the locations of these particular points. And there's a whole bunch of problems that you're going to do right at the beginning, I believe. Let me just look. Yep, they give you a graph, and they got points scattered all over this graph. And they're all labeled, A, B, C, D, E, F, G. And they're going to ask you, what are the coordinates of those particular points? So what would your answer be? On point A, it would just be 3, 2. That's as easy as that. They take just a second, really, just to count over, maybe a couple seconds. Count over this far, count up this far, 3, 2. Pretty simple. Let's do another one. Let's go down, or let's go up here. Let's go right there. And that, let's say we call that point B. What would the coordinate of that point be? Is it 1, 4? It's -1, right, because we're going to the left. That's very, very important. Okay, because 1, 4 would be at a completely different spot, wouldn't it? 1, 4 would be right here. But this point is at -1, 4. So write that in there, -1, 4. That's how you find the coordinate of that one. Let's do a couple more. Let's do, let's put a point right here. I'll tell you what, let's get rid of that. Let's get rid of that. Okay. -3, -2? -2, -2, right. Okay, because watch, you start here at the origin, and you go to the left. See, this is right above the dot, so you go to -2 first. You always go left and right first. All right, so you start at the origin, the beginning, go to the left 2 places, and then go down 2 places. So we went -2, and then we went -2. So we'll call that point C, and the coordinate is -2, -2. Everybody with me so far? Let's do one more. Oh, you know what I forgot to tell the other class? See how this coordinate system is broken down into 4 big old chunks right here? See how you have this area, this one, and this one? You remember what you call those things? Quadrants, that's right. And how do we label the quadrants, do you remember? With a Roman numeral. Right, so this is the first what? Quadrant. I'll write that word down. Okay, quadrant. Now, we always start at the top right, and we move counterclockwise. So if this is the first one, what quadrant would this be? The second, and then the 3, and then 4. Everybody with me on that? Okay, so I forgot to say that in the last class, but I got it on here. Let's go in the 4th quadrant now, and let's I don't know, let's put one right there. That point right there, we'll call it point D. What is the coordinate of point D? 4, what? -2. Very good. Okay, so just put 4, -2. All right, everybody good with that? Let's trick you up just a little bit. What if, let's go bright color. What if we put one right here? Right on the y-axis. 0, 3. That's good. A lot of people mess this up, okay? You start here, don't you? Do you have to go left and right in order to get up to that point?
No.
No, you go 0 places, don't you? All right, so you go 0, but then you go straight up. That's the second part of it, and that's 3. So that's 0, 3. What about this point right here? 0, -4? Think of the order that you have to go. Start here. Which way do you go? You go left and right first. Right, so you got to go -4 first, right? Because you go X and Y horizontally first. And then you go how far up and down? You go 0. Getting this? You're writing this stuff down, right? Yes, sir. We'll talk about that later. That's talking about slopes. We're not going to do that in this lesson. But we will have a chapter where we do a lot of this stuff. It's going to be a lot later in the year, and we'll get into this a lot more detail than what we are getting right now. Okay, all I'm concerned about for right now is just knowing the ordered pairs and all that kind of stuff. Okay, yeah, it does get a lot more complicated, and you're talking about slopes and all that. We'll do that a little bit later, not today. All right, let's see what else. I think we pretty much covered everything. All right, now there's basically 2 ways that they could ask questions here. They could do this. They could put these points and label them, A, B, C, D. And you have to tell the coordinate of that point, so you write it as an ordered pair. What do you think would be another way that they could ask you a question about ordered pairs? They could do what? They could tell you to mark it. That's right. Exactly right. They could, say, okay, here's a point, -3, 1. All right? They'll give you a point, -3, 1, and what do you have to do? You have to draw the graph and put it on the graph, right? Okay, what they would do is they would say, I think they would say plot the point. Okay, so they use that word plot. Or sometimes they might say graph it. It could be used interchangeably. All right, they could say plot the point or graph the point. Either way means it's do the same thing. So if they said -3, 1, then what would you do? You would make your own X and Y axis, wouldn't you? And then you would put some points on here. And you don't need graph paper. If you want to use graph paper, you can. You don't have to, though. Everybody hear me? Okay, you can use it if you want, but you don't have to. If you have it, use it. So where's negative 3, 1? Well, negative 3, 1, so you put it right there, and there it is. We'll call it point A or something, all right? So that's a little bit different. They give you the point, you have to plot the point. That shouldn't be too hard, right? If you do one, you should be able to do the other. It shouldn't be that big of a deal, all right? Let me do an example. We got just enough time to do this. Let me give you an example. Let's make another x and y axis here. We'll scooch it down a little bit like that. Okay. Let's actually make this white. There we go. This blue. All right. Here's an example. It's actually in the book. It's on flip page. It's on page P16. And they say graph a polygon with these certain vertices. So now they're throwing a couple words at you that you haven't seen before. A polygon is basically just a shape. And a vertex, now they said vertices. I'll tell you what, let me just draw this thing right here. This right here would be a polygon, right? Because it's a four-sided figure. It could be any side. It could be 3, 4, 5, 6, 7 sides, okay? It happens to be a four-sided polygon. And look where they connect. Do you see where those two sides hit right there? They make a point. We call that thing a vertex. The whole thing is called a polygon. That's a vertex. How many of these I hate to say it. Let's say the plural. The plural is vertices. That's supposed to be a C. V-E-R-T-I-C-E-S. That's the plural of vertex. So you have one vertex and you have 2, 3, 4 what? Vertices, okay? Vertices. That doesn't look too nice, but V-E-R-T-I-C-E-S. So you got 4 vertices. Okay, that's what they're talking about right here. So they threw a couple words at you that they haven't really defined or explained yet, but that's what they are. So here's what they give you. They give you points A, B, C, and D. A, B, C, and D. And they tell you the ordered pairs for each of these 4 points. And what you have to do is you just have to graph it on this coordinate plane or this coordinate system. All right, so let's put the points in here. We've got A is negative 3, 3, negative 3, 3. B is 1, 3. C is 0, 1. And then D is negative 4, 1. All right, so let's put some marks in here. 1, 2, 3, 4. Let's go over 4. I don't even need any down here, do I? Because I don't have any negatives. All right, so let's do this. Negative 3, 3. Let's plot it. Negative 3, 1, 2, 3, and then up 3, 1, 2, 3. I'd say about right there. Does that look pretty close? All right, 1, 3. Let's go 1, 3. Start at the origin, go to the right 1, and go up 3. That would put it right there. And then you go 0, 1. So you go 0 on the x, and you go up 1. So you put a dot right there. We're almost done. One more. Negative 4, 1. So we go to the left 4, 1, 2, 3, 4, and we go up 1. So we've got it right there. Now, we want to draw the polygon, all right? It's got to be a shape. It's got to have sides. So what do you think we're going to do with these points? Connect them, right. Okay, so connect from here to here. Now, that should go straight across. I might have not been super accurate, but it should be pretty close. And I connect from here to here, connect from here to here, and then from there to there, all right? And there you go. You got a cool-looking polygon. So it's a four-sided polygon, right? And these are the vertices. Which one was A? Negative 3, 3. That was A, right? Which one was B? 1, 3. So this one up here was B. C was 0, 1. And then D was negative 4, 1. There you go. So there's your polygon with the points labeled. This is what I want to see when they ask you to do something like this. Does that make sense? It's not too hard, is it? You know how to plot the points. All you have to do is just connect the lines, make a nice polygon out of it, and you're good to go. Yes? I'll give it to you. I always give it to you. All right, here we go. This is what we're doing. It's section 07. It's page P16. So it's page P16. Now look, this sounds like it's a lot of problems to do, but it's really not at all, because some of them are just so easy. 1 to 26. Okay, so 1 to 26. All right. So there it is. That's your homework. Get that done. It shouldn't take you that long at all. So it's 26 problems, which really are really simple. It's even easier than this one right here. All right, have fun with that.